Hello students, welcome to the class. In the last class, we discussed laws of motion, all the synopsis part. So from today's class, let us see MCQ questions based on this chapter. Okay, so first we will see concept related, then we will see the application based, then we can go for the previous year question paper questions, right? So that it will be helpful for you, right? So our first question is from the laws of motion chapter. First question is swimming is possible on account of. So we discussed Newton's laws of motion, first law, second law, and third law. So in all the three laws we discussed in detail, the examples also. So here they have given the options like Newton's first law, second law, third law, and Newton's law of gravitation. So as we know that first law is called as what? Law of inertia. Second law is called as what? Law of acceleration. And the third law is called as law of interaction, right? So swimming, how this swimming takes place, or how swimming is possible. Here what happens whenever you are swimming, or if you observe a swimmer, he will push his hands in the back, means he water in the backward direction, so that is action. And then next, what happens in reply, the body will move in the forward direction, so that is what? Action and reaction pair. So therefore here Newton's third law of motion we can explain with the help of Newton's third law of motion, that is swimming phenomena, right? So the correct option is option C. The correct option is option C here. That is Newton's third law of motion. What is the statement of Newton's third law of motion? For every action, there is equal and opposite reaction. So here action is you are moving the water in the backward direction, and reaction is your body is moving in the forward direction. That is reaction. Okay, so the correct option is option C. That is Newton's third law of motion. Then our next question. Second question is inertia is that property of a body by virtue of which the body is. So we know that inertia definition, we know types of inertia also we have discussed. So here the question is inertia is that property of a body by virtue of which the body is. So options are unable to change by itself the state of rest, unable to change by itself the state of uniform motion, unable to change by itself the direction of motion. And option D is what? All the above. So here students, that is, as we know that there are three types of inertia. There are three types of inertia. So one is inertia of rest, and the second one is inertia of motion, and the third one is inertia of direction. So here what happens, that is, in case of, that is inertia of rest, here what happens, inertia is nothing but what? To oppose the change, to oppose the change. If the body is at rest, it will oppose the change to be in the motion state, right? The inertia of motion is what? If the body is already in motion, it opposes to come to the rest. Inertia of direction, here the body will oppose the direction change here. So here the correct option is option D, that is all the above. That is inertia of rest states that unable to change itself, that state of rest. Inertia of motion states that unable to change itself, the state of uniform motion. And inertia of direction states that unable to change by itself the direction of motion. So all the three options are correct. Therefore, the correct option is all the above. All the above, right? So let us see the next question. Option C. Sorry, third question. An object will continue moving uniformly when. So here what they're asking, the object is moving uniformly. So when it is possible. Option A, the resultant force on it is increasing continuously. Option B, the resultant force is at right angles to its rotation. Third, the resultant force on it is zero. Fourth option, the resultant force on it begins to decrease. So when we can say that the body is moving uniformly, see here students, option A, what they are saying, the resultant force is increasing continuously. So when the resulting force is increasing continuously, what happens? Obviously, the motion will also increase, right? Force is increasing, force and motion are directly proportional. Second option, the resultant force is at right angles to its rotation. So here the resultant force is right angle. Here they have not mentioned that whether it is increasing or decreasing. So here this is also not correct. Then option C, the resultant force on it is zero. So fourth option is the resultant force on it begins to decrease. So when the resultant force starts to decrease, here what happens? The motion also decrease. Continue whatever it is there. It will not be uniform, right? So here the correct option is option C. The correct option is option C here. The resultant force on it is zero. The resultant force is what? Zero here, right? Then only it is possible for the body to maintain the uniform motion. Option C is the correct option. Option C is the correct option. Our next question. A man getting down a running bus falls forward because. So this is also again the inertia concept. Here, if you remember the example for inertia of rest and inertia of motion, based on that, you can explain. Same concept it was there. A man getting down a running bus falls forward because of inertia of rest. Road is left behind and man reaches the forward. Option B, inertia of motion, upper part of the body continues to be in motion in forward direction while feet come to rest as soon as the touch the road. He leans forward as a matter of habit. Option D, of the combined effect of the three factors stated in 1, 2, and 3. So option D is not at all possible. All the three we cannot observe at one time. Option C is also not possible. So it is not because of the habit of a person. So either it is A or B. So which one is correct here? See, here the question or the scenario is what? A man getting down from a running bus means already it is in a motion. So option B is the correct option. That is, it is because of inertia of motion, upper part of body continues to be in motion in forward direction while feet come to rest as soon as they touch the road. Getting? So this is what? This is because of inertia of motion. Therefore, the correct option is option B. Option B is the correct option. Fifth question. A man is at rest. A man is at rest in the middle of a pond of perfectly smooth ice. Okay, he is at rest. He can get himself to the shore by making use of Newton's. So what they are saying, Newton's which law is applicable here, that you need to understand. He is at rest position, that too he is at the middle of the pond, which is a perfectly smooth ice. He can get himself to the shore by making use of Newton's. So first law is not possible, second law is also not possible. So the correct option is option C, that is third law. So because of the third law of motion, the man will settle to the shore or seashore or the edge of the river here. Okay, next question. A cannon after firing recoils due to. So here what it is, a cannon after firing recoils due to. It is because of conservation of energy or backward thrust of gases produced. Option C, Newton's third law of motion. Option D, Newton's first law of motion. So here, that is a cannon after firing recoils. This is again a said pair of action and reaction. Therefore, here it is Newton's third law of motion. This is because of Newton's third law of motion, right? Next question. Newton's second law measures the. See here. Also from Newton's second law, what we can calculate? Whether it is acceleration or it is force or momentum or angular momentum. See here, the Newton's second law measures what by second law what we come across. What is the statement of second law here? Second law states that is the rate of change of momentum is directly proportional to the applied force. Here by using that concept we come across a derivation. So where at the end we derive that F is equal to m into A. So Newton's second law measures the force here, that is force is equal to mass into acceleration. So the correct option is option B. Option B is the correct option. That is Newton's second law of motion measures the force of a body. Getting right? Next question. We can derive Newton's, see, that is second and third law from the first law. You need to understand this question properly. So there are three laws of motion, that is first law, second law, third law. So what they are asking here, by which law you can derive the other law, that is the meaning of the question. So we can derive Newton's second and third laws from the first law. Is it true? Next, first and second laws from the third law. Third option, third and first law from the second law. Then option D, all the three laws are independent of each other. See, option D is not at all correct. All the three laws are independent of each other. This is highly impossible factor. Why? Because see, what is that first law states? First law states that whenever any force is applied on a body, the body will change the position either from rest to motion or motion to rest. Means here if there is no force, the body will not change its position. Second law, what it says, that is second law states that whenever the body is moving, its momentum changes, that is directly proportional to the force applied. Third law is what? Action and reaction pair. So here all the three laws are depending on each other. But from how? See, the correct option is option C, that is third and first laws from the second law. Why? Because in the first law as well as in the third law, we use the concept of force. So that force concept is derived from the second law here. Therefore, we can derive Newton's third and first laws from the second law. So the correct option is option C. Option C is the correct option. That is third and first laws from the second law. Next question. A jet plane moves up in air because. So here a jet plane which is moving up in air because of what? See here the options are: the gravity does not act on bodies moving with high speed. Second option, the thrust of the jet compensates for the force of gravity. Third, the flow of air around the wings causes an upward force which compensates for the force of gravity. Fourth option, the weight of air whose volume is equal to the volume of the plane is more than the weight of the plane. So why this jet plane moves in air upward? That is, first option is what? Gravity does not act. So it is not true. Gravity always acts on each and every body on the earth. Second option, the thrust of the jet compensates for the force of gravity. So here, whatever the thrust is nothing but what? Pressure type. Okay, there is force perpendicular to the area is thrust here. So what they are saying, the thrust of the jet compensates for the force of gravity. Means here, whatever the gravity is there, that force is equal to the thrust exerted by the jet plane. Because of that reason, it moves in the upward direction. Therefore, the correct option is option B. Option B is the correct option here. Okay. Right. Option B is the correct option. Option C, what they have given, just we will see that the flow of air around the wings causes an upward force which compensates for the force of gravity. No, it is not true. The weight of the air whose volume is equal to the volume of the plane is more than the weight of the plane. No. So here the correct option is what? Option B. The thrust of the jet compensates for the force of gravity. Right? Next question. When a body is stationary. So when we can say that the body isn't stationary, first option, when there is no force acting on it. Second option, the force acting on it is not in contact with it. Third option, the combination of force acting on it balances each other. Fourth option, the body is in vacuum. Okay. So see here students, if you see the options, you feel that all the options are similar. So if you don't know the concept, some student may mark it as there is no force acting on it, therefore the body is that stationary. No, it is not true. Why? Because here always the at least a gravitational force will be acting on the body. Right. Second option, the force acting on it is not in contact with it. This is also not true. Why? Because whatever the gravitational force is acting on a body, it is not a what? It is not a contact force. It is a non-contact force. So here, if it is there, then also the body is at stationary, which means that the combination of forces acting on it balances each other. Means here, two forces always it is acting on a body. You know, I think you people remember this one. That is whenever. Suppose on this table, if any one book or any ball is placed, this is at rest in the sense or stationary in the sense, the weight of the ball, that is m into g, is acting in the downward direction, and the normal force which is acting in the upward direction. So when these two forces are balanced, that is normal force and the weight of the body is balanced or compensating each other, then the body will remain at rest. Otherwise, either it will fly, means it will float, may go up or it may fall down. So here when they balance each other, the body remains at stationary. Next, the body is in vacuum. No, that is also not possible. Right. So here the correct option is option C. The combination of forces acting is balancing it. Okay. Next question, 11th question. Tension is the cable supporting an elevator. Tension in the cable is supporting an elevator, which is equal to the weight of the elevator. Which is equal to what? Weight of the elevator. From this, we can conclude that the elevator is going up or down with A. So here, see here students, what they are saying, that is, you have an elevator. So I hope you know the meaning of elevator. So this elevator is suspended by, or it is supported by a tension in the cable. So it is supported by a tension in the cable, which is equal to the weight of the elevator. So this is obvious that whatever the tension in the cable is there, that must be equal to the weight of the elevator. Then only it is possible to balance it. From this, we can conclude that the elevator is going up or down with. So because of this concept, because of which concept, that is tension in the cable, which is supporting the elevator, and the weight of the elevator are equal. Because of that reason, which option is correct? That it is moving up and down with uniform velocity or uniform acceleration or variable acceleration, or option D is either B or C. See here students, so we know that when two forces are balancing here, when they are equal, the body moves with a uniform velocity. So whenever you are using a elevator, you might have experienced this. So uniform velocity, with uniform velocity it will be moving. It is not that when it is at the lower point it is moving up, upper point moving slow. It is not like that. So it is moving with uniform velocity. So the correct option is option A. Option A is the correct option here. Next question. The force exerted by the floor of an elevator on the foot of a person standing there is more than his weight. If the elevator is, see here what they are saying, the force exerted by the floor of an elevator, the force exerted by an floor of an elevator on the foot of a person standing there is more than his weight, right? If the elevator is, so here you need to understand which statement is true. When it is going down and slowing down, when it's going up and speeding up, when it is going up and slowing down, option D, either A or B. See here, that is, you might have experienced this one, that is the force experienced in the elevator when the person is standing inside, it is more than his weight. If the elevator is, so when you will experience this one, when the elevator is going up or speeding up, then we experience this. What we experience, the force exerted by the floor of an elevator on the foot of the person standing is more than his weight. So option B is the correct option. Option B is the correct option, that when it is going up and speeding up. Option B is the correct option. Next question. A reference frame attached to Earth cannot be an inertial frame because. So students, I think in the last chapters, you might have studied regarding the reference frame. So what is reference frame? In reference frame, two types are there. That is inertial frame and non-inertial frame. So a reference frame attached to Earth cannot be an inertial frame. Why? See, option A. That is, Earth is revolving around the sun. Earth is rotating about its axis. Newton's law are applicable in this frame. Option D, both A and B. See here, in case of inertial frame, a frame attached to Earth cannot be an inertial frame because here, why? Because Newton's laws are applicable in this frame and Earth is rotating about its axis. So here both the options are correct. Therefore, option D is the correct option. That is, sorry, option D, that is both A and B. That is, Earth is revolving around the sun. This is true. And Newton's laws are also applicable in this frame. Therefore, a reference frame attached to Earth cannot be an inertial frame, right? It cannot be an inertial frame because of these two reasons. So two reasons are right. That is A and C. Therefore, the option D is correct. That is, Earth is revolving around the sun as well as Newton's laws are applicable in this frame. Next question. When an elevator cabin falls down, the cabin and all the bodies fixed in the cabin are accelerated with respect to. See, when an elevator cabin falls down, so when it is coming down, the cabin and all the bodies fixed in the cabin are accelerated with respect to. Option A, ceiling of elevator, floor of elevator, man standing on the earth, man standing in the cabin. A man standing on earth. So when an elevator cabin falls down, the cabin and all the bodies fixed in the cabin are accelerated with respect to. So here we compare with respect to the man standing on the earth. So that is option C is the correct option. Okay. Then next question is question number 15. A particle is found to be at rest when seen from frame S1 and moving with a constant velocity when seen from another frame S2. Mark out the possible option. See, S1 is inertial, S2 is non-inertial. Both frames are non-inertial. Both frames are inertial, either B or C. So what they are saying, a particle is found to be at rest when it is seen from frame S1 and moving with a constant velocity when seen from another frame S2. So which is possible here? So what we can say? We can say that either both frames are inertial or non-inertial. That is option D is the correct option. Option D is the correct option. Either B or C. Correct. Option D is the correct option. Next question. When a bus suddenly takes a turn, the passengers are thrown outward because of. So because of what the passengers are thrown out? So here option A, that is inertia of rest. Option B, acceleration of motion. Option C, speed of motion. Option D, both B and C. Here if you see the question, if it is taking a turn, actual answer is what? Inertia of direction, right? Which is the appropriate answer. But here the appropriate answer, that is inertia of direction, is not given. So inertia of rest is there. This also we can consider. Why? Because here when the bus suddenly takes a turn, here what happens? The body is adjusted for one motion. So here that is, it is particular to that. Therefore, we can consider it as what? Inertia of rest. Or else inertia of direction, if it is there, directly we can mark it. Option A is the correct option. That is inertia of rest. That is inertia of rest. Okay. Next question. A train is moving with velocity 20 minutes per second. On this, dust is falling at the rate of 50 kg per minute. The extra force required to move this train with constant velocity will be. So here, student, you need to calculate force. So force is equal to what? Mass into acceleration. So mass, what they have given, see, there's 50 kg per minute and velocity is given 20 meter per second. So how we can solve it? So here onwards, the numericals will start. Till now we discussed little theory based type questions. Now, see, that is, we know that force is equal to mass into acceleration. This acceleration can be written as what? Rate of change of velocity. So therefore, instead of writing this, I can write it as V into dm divided by dt. Right. So what is velocity? Velocity is 20 meter per second. No need to convert anything here. Okay, just write it as 20 into. So 20 into dm divided by dt. So dm divided by dt is nothing but what? How much they have mentioned? See, they have given it as 50 kg per minute. So per minute means divided by 60. So this 0 I can cancel. Therefore 20 into 5, that is 100 divided by 6. So 100 divided by 6, if you simplify it, is 16.66 Newton. It is 16.66 Newton. That is option A is the correct option here. Option A is the correct option, 16.66. So how we need to do? We can use force is equal to mass into acceleration. There we can little rearrange the terms and we can take it as. Why we are doing like this? Because they have given mass in terms of, that is, rate of mass they have given. Therefore, we need to take in this way. The correct option is option A, 16.66 Newton. Okay, simple one. Next question. A vehicle of 100 kg is moving with a velocity of 5 meter per second. So what they have given, a vehicle is moving with a velocity of 5 meter per second. To stop it in 1 by 80, 1 by 10 second, the required force in opposite direction in. So again here you need to calculate the force. They have mentioned it as opposite direction, in the sense you need not use to any different formula. Here force formula only we can use. If the answer, if you are getting in terms of negative, which means that it is in the opposite direction. So the simplification part is so what all given terms are there? See, mass is equal to, they have given it as 100 kg. Then next, velocity, they have given it as 5 meter per second. To stop it in 1 by 10 second, they have given, means the final velocity, it is that it is 0, right? So what we can use formula? Formula is mass into force is equal to mass into acceleration, which implies mass into rate of change of velocity, which is equal to, or we can also write it as final velocity minus initial velocity divided by time, means change in velocity is called as what? Acceleration. So now substitute. This is equal to mass is 100 into bracket final velocity is 0 minus initial velocity is how much? 5 divided by time. So to stop it in 1 by 10 second, 1 by 10 second means what? 1 by 10 is equal to, we can take this time as 0.1 second. So that is nothing but 0.1. So 0.1, therefore, so 100 into 5, that is 5,000, right? So that is 100 into 5, sorry, 500. So 500 divided by, we have 0.1. We have 0.1. So that is nothing but what? That is 5,000. Right? Or instead of that, you can also take one more step here. Like, sorry. This is equal to, so this is 100 divided by 0.1. 100 divided by 0.1 is nothing but what? 1 divided by 10. This 0.1 can be written as 1 divided by 10 itself. So if it goes to the numerator, it becomes 1000. It becomes 1000 into minus 5. So that is nothing but minus 5000 Newton. That is minus 5000 Newton. So in the option, they have not given minus sign. But in the question itself, it is written that it is required a force in opposite direction. So that is 5000 Newton. Minus indicates it is in the opposite direction. Therefore, the correct option is option A. Option A is the correct option. 5000 Newton. Okay, you can copy this. First, you need to understand what all given quantities are there, where all it can be used. And the appropriate formula. First concept is, in solving physics sum, we need to understand what are the given quantities are there, whether we require any conversion or what. Then we need to come for the formula which is related, which is approximately related to the sum. Always we need to choose the formula which has only one unknown term, then it is appropriate for the given numerical, right? So if any two unknowns are there, you can see that whether with the other formula can you calculate it or no. So in these all sense, when you think the solving numericals in MCQs, it will be easy. Okay, so here I'm showing you stepwise. Directly you can take the in one step or in one two step you can simplify this sum, right? So that is Force is equal to mass into acceleration. Acceleration, you can take it as change in velocity by time. Directly you can substitute the values and you can solve it. So option A is the correct option, 5000 Newton. Next question. Three forces starts acting simultaneously on a particle which is moving with velocity. So here what they are saying, three forces starts acting simultaneously. So it is acting simultaneously on a particle which is moving with velocity, okay, which is moving with some velocity here. These forces are represented in magnitude and direction by the three sides of triangle ABC. In the given figure, you can see that. Okay, so here the forces or the sides of a triangle are denoted as ABC. The particle will now move with velocity. Particle will now move with a velocity. How we can do it? See. Here, only the thing is we need to understand the concept. So, as we know that the three forces are in equilibrium. The three forces are in equilibrium. What they are saying, acting simultaneously on a particle. Okay, these three forces are represented in magnitude by the three sides of this triangle. The particle will now move with velocity. So with what velocity it will move? See, the given three forces are in equilibrium. That is, the net force will be 0. Okay. So when three forces are acting simultaneously, here the net force will be 0. It means the particle will move with the same velocity. So options what they have given, V remaining unchanged, then next greater than V, then option D, V in the direction of the largest force BC. Okay. So here when the three simultaneously forces are acting, the net force will be 0. Therefore, V is remaining unchanged. V is remaining unchanged. That is option A is the correct option. Okay, in option B, it should be remaining, there is a small mistake in the option B. So option A you will take, that is V is remaining unchanged here. V is remaining unchanged is the correct option. Okay, so option A is the correct option. Then our next question is, two forces are such that the sum of their magnitude is 18 Newton. The sum of the magnitude is how much? 18 Newton. And the resultant is perpendicular to the smaller force and magnitude of resultant is 12. Then the magnitudes of the forces are. So how we need to do? Here options are given like 12, 6, 13, 5, 10, 8, 16 and 2. So these are the given options. So according to the question, you can draw one figure for the understanding purpose. Okay. See here what we can take. The two forces are there. One force I can take it as F1. Okay, another force I can take it as F2. The resultant I can take here. The resultant is given as 12. Okay, so here the resultant is perpendicular. Okay, little. This is perpendicular and this angle is theta. Now, according to the question, what all it is given, just see. That is, here the two forces are there, that is F1 and F2. F1 and F2 are the two forces which it is given. The two forces such that the sum of their magnitude is, how much they are saying, 18 Newton. So according to the given data, I'll write it as F1 plus F2 is equal to 18. What is the meaning here? The sum of the magnitude is 18 Newton. This is your equation 1. Then, and the resultant is perpendicular. So what they are saying, the resultant is perpendicular in the sense, the theta value is how much? 90 degree. The resultant is 90 degree to the smaller force, and magnitude of resultant is 12, and the magnitude of resultant is how much? It is given as 12. The angle between F1 and R is 90 degree. Okay. So one force is smaller and one force is bigger, that we need to understand. Here we can take it as F1 is less than F2. F1 is less than F2, we can assume. Okay. Now, what is the angle formula here? The angle between F1 and F2, sorry, R is 90 degree. What is the formula? So in the synopsis, you have seen that is tan alpha is equal to, we have taken. So here tan 90 or tan theta value is how much? It is 90, which is equal to, the formula is F2 sine theta divided by F1 plus F2 cos theta. So now, what is tan 90 degree? Tan 90 is infinity. So which is equal to, we can write it as, so this expression we can write, therefore we can also write it as, if I transfer this infinity to the other side, here I'll just write it F2 sine theta divided by F1 plus F2 cos theta. Therefore, it becomes, I can write it as F1 plus F2 cos theta is equal to F2 sine theta divided by infinity. So anything divided by infinity, what is the value here, students? If anything divided by infinity is how much? It is 0. It is 0. Here we can take it as 0. Therefore, here what we got, we are getting it as F1 plus F2 cos theta is equal to 0. Okay. Or we can also write it as cos theta is equal to minus F1 divided by F2. This is our equation 2. This is our equation 2. What is our equation 1? Equation 1 is F1 plus F2 is equal to 18. Equation 2 is what? Cos theta is equal to minus F1 divided by F2. Right? Now, what we can do, the resultant is given by, so here tan 90, what I have written, that is angle. Now I can take the resultant formula. So what is the resultant formula? The resultant formula is, it is actually what? R is equal to root of F1 square plus F2 square plus 2 F1 F2 into cos theta. So instead of that, I'll take it as R square. So I don't want to take it in a root. So I just want to take it in a simplified form. That is R square is equal to F1 square plus F2 square plus 2 F1 into F2 into cos theta. Okay. So what is R? The resultant value they have given here in the figure, you can see. In the figure here, it is, our resultant value is how much? It is 12. So in the R value, we can substitute 12 square. How much is 12 square? That is 144 is equal to F1 square plus F2 square plus 2 F1 into F2 cos theta. This I'll take it as equation 3. Now you see here, students, equation 1, equation 2 and equation 3. Before telling the next step, I just want to revise it. So what the question is, two forces are there, F1 and F2. The sum of their magnitude is 18, it is written. Therefore, according to that, I am writing my equation 1. That is F1 plus F2 is equal to 18. Right. Next, and the resultant is perpendicular to the smaller force, and magnitude of the resultant is 12. So resultant is 12, that is R is equal to 12 they have given. And the angle between the resultant and the smaller force is 90 degree. So according to that, the angle formula we have, that is tan alpha is equal to F2 sine theta divided by F1 plus F2 cos theta. Here, the alpha value or the theta value, how much they have given? It is 90 degree. So what is tan 90? Tan 90 is infinity, which is equal to F2 sine theta divided by F1 plus F2 cos theta. Okay, so I'll just rearrange the term. F1 plus F2 cos theta, if I take it on the other side, it becomes F1 plus F2 is equal to cos theta is equal to F2 sin theta by infinity. So anything divided by infinity is 0, right? Therefore, we are getting finally F1 plus F2 cos theta is equal to 0. Therefore, if I want to simplify it for cos theta, if I want to simplify it for cos theta, then cos theta is equal to minus F1 by F2. This is your equation 2. Here, they have asked you to calculate the magnitude of the force. To calculate the magnitude of the force, we need to take the resultant formula, that is r square is equal to F1 square plus F2 square plus 2 F1 F2 into cos theta. R value in the question itself is given. The resultant is 12. Therefore, 12 square is 144, which is equal to F1 square plus F2 square plus 2 F1 F2 into cos theta. That is equal to equation 3. Now here the important step is, now if you observe equation 1, equation 2 and equation 3. So what is equation 1? That is F1 plus F2 is equal to 18. What is your equation 2? Cos theta is equal to minus F1 by F2. What is equation 3? 144 is equal to F1 square plus F2 square is plus 2 F1 F2 into cos theta. By solving this all three equations, we can get the value of F1 and F2. We can get the value of F1 and F2. So how we can simplify? I hope you know this one. Here you can just substitute the value of F1 plus F2 and cos theta value, and further simplification, if you try to do it, the value of F1 and F2 is found to be, that is 13 Newton and 5 Newton. Here you can do two steps here, students. One is you can take option A, 12 Newton, 6 Newton, substitute. Just check whether you are getting the correct answer or no. Then B, C, D, like that you can do verification, you can do for all the options, or you can go for this simplification of equation 1, 2 and 3. So if you substitute and simplify further, you are getting option B, that is 13 Newton and 5 Newton. The correct option is option B. Just copy down this. Option B is the correct option. Okay. Option B is correct option. Then let us see one last sum for today's class. Then our next question is, okay. Next question is, mass M is suspended by a rope or from a rigid support. You can see how it is suspended from a rigid support as shown in the figure. Another rope is tied at the end Q and is pulled horizontally with the force F. I hope you are able to see in the figure clearly. So how it is M is suspended and supported. If the rope PQ makes angle theta, if it is making angle theta with the vertical, then the tension in the string PQ, So from the figure you can sort out and you can draw one more figure for your understanding. That is, you can consider, that is, this is your F force. Okay, so here the mass is acting in the downward direction. The weight is mg. We can resolve this tension T. Here the tension, resultant tension T will be there. We can resolve it as T cos theta, and here it is T sine theta. T cos theta and T sine theta. So for horizontal equilibrium, we have T sine theta is equal to F. Can you see here the horizontal component are F? One direction, T sine theta is one direction. Therefore, T sine theta is equal to it is F. Therefore, we can write T is equal to tension in the string PQT is equal to it is F divided by sine theta. It is F divided by sine theta. That is option B is the correct option. Option B is the correct option here. Okay. So how we did? We need to take whatever the question is given. A mass M is suspended with the rope. Okay. Which is shown in the figure. Another rope is tied, which is tied at the point Q, that is in the horizontal direction. If the rope PQ makes angle theta, here you can see in the figure, it is making an angle theta. Here the theta angle is there. Okay, so according to this, I just have taken the figure. So this is your F force and this is the tension T. We can resolve it into two components. So by that, we can see that the horizontal equilibrium is given by T sine theta is equal to F. Therefore, it is T is equal to F divided by sine theta. That is option B is the correct option. Option B is the correct option. Okay, students. So in today's class, we have seen the examples for MCQs questions for inertia, Newton's laws, right? And tension in the string and all. So based on Newton's second law formula, these all concepts we used equilibrium and we solved the numericals today. So in further, whatever the concepts we discussed earlier, based on that, let us see few more questions in the next class. Okay, thank you.